This tutorial illustrates the use of restraints. Let's build a molecule. Let's build ethylene. And then let's optimize this planar structure. Ethylene is, of course, planar. And let's optimize this, and let's use the semi-empirical method for speed here. Let's just choose PM3, and we'll do a geometry optimization of this. So this gives us a bond length of 1.32 angstroms for ethylene, and an angle here of about 113 degrees. Now supposing we were wondering what this would be in the twisted form, where this instead of planar here we have the two ends at 90 degrees to each other. How would we do that? Well, in HyperChem you have the general restraint possibility. That is, you can take a 1 atom, 2 atom, 3 atom, or 4 atom selection and restrain that using additional molecular mechanics force constants and potentials. And this is added on top of any other molecular mechanics or quantum mechanical methodology that you're using. A restraint basically adds an extra molecular mechanics term to restrain the geometric variable that you are talking about to particular values. Now this restraint is not absolute, it is not a constraint, it is only a restraint because it uses a force constant which is finite, and so we restrain a geometric variable to be in the region of a particular value. In this case, if we're going to want this to be 90 degrees, we'll have to take these angles, these torsional angles. Let's name this one, we'll call this twist, and then we'll call this one, the other one, and name this twist 2. So we have two torsions defined that we would like to be, instead of trans or 180 degrees, we'd like them to be cis, not cis, but 90 degrees rather. So what we do is we go up and we hit restraints. Now this menu item was grayed out until we had defined via a named selection some variables that we could restrain. We can't restrain anything until we name the thing that we want to restrain. So this is now enabled because we've defined some restraints. We've defined some variables. We've actually defined two variables, two 4-atom variables. Again, these could be 3-atom variables, 2-atom variables, or 1-atom variable. A 1-atom variable will be a tether as opposed to a real restraint of a bond distance, angle, or torsion. So anyway, these are the two variables. Let's add them to the restraint list. And this first one is at currently 180, and we want this to be 90. And the force constant, this is some default value. Let's bump it up to a big number like 1,000 to put a good restraint on here. Again, the restraint is the strength of the restraint is determined by the force constant we use, and even that will be a finite restraint, not an absolute constraint. The other one too, we'll make that sort of 90 degrees. And we'll make this force constant 1,000. So now we have restrained these two variables, and if we go ahead and do the optimization again, what did I? What's 90, 90, 90? Okay. Why doesn't this go here? It's because I got 180 degrees here, or what? Let me twist this some 170 just to get started here, and then start the optimization. I guess because it's planar again, there's no forces out of the plane, and so now we get the result that we want. This is a twisted ethylene, and again, there's often a problem with molecules that are planar when you optimize. Initially, there's no way to have a force that's perpendicular to the plane if it's absolutely in a plane, and if the structure that you want is non-planar and you start with a planar form, you may stay at the planar form. This is a general problem of optimization in that using first derivatives, and it only knows, it cannot have a force perpendicular to the plane if it's in a plane. Anyway, so here's now the twisted ethylene that we've restrained, and the bond length now is 1.36. So the bond length in the twisted molecule is considerably longer than it was before, and the angle, I guess, it's comparable. I don't remember. It was 113 or something before, so that hasn't changed very much. But the bond has stretched in the 90-degree molecule. Anyway, that is the use of restraints. There's other uses to tether things or to basically add a restraint for various reasons. You want to restrain a molecule in a particular position, restrain its conformation, and so on, and this is the way that you add those restraints.